Hello, I'm Edward Tarte, math teacher. This is another in a series of solution videos to some of my math challenges. The math challenge for this solution video is my challenge from triangle to square. Here is how I presented that challenge in the original video. Consider the set of what we call triangular numbers, as shown here: 1, 3, 6, 10, 15, and so on indefinitely. Take a triangular number, multiply it by 8, then add 1. For example, we could take the triangular number 6. We start with 6, multiply it by 8, which gives 48, then add 1, which gives 49. Now 49 is 7 squared, that is, it's 7 times itself. Now 7 happens to be an odd number. 49 being 7 squared, 49 then is the square of an odd number. Let us take another example. 10 is a triangular number. Take that triangular number 10, multiply it by 8, that's 80, then add 1, that's 81. 81 is 9 times 9, 9 squared. And that is another example of getting an odd number squared. So here's the challenge. Prove that if you take any triangular number whatsoever, multiply it by 8, then add 1, you will always get the square of an odd number. Here's my solution. I'm showing here the first 5 triangular numbers presented as half of a rectangle. The first one is shown as half of a 1 by 2 rectangle, giving the triangular number 1, shown in black, the black circle. Next we have a 2 by 3 rectangle, the 3 black circles, half of it, that's the triangular number 3. Next we have a 3 by 4 rectangle, half of that gives the 6 black circles. A 4 by 5 triangle, half of that gives the 10 black circles. A 5 by 6 rectangle, half of that gives the 15 black circles. That's the triangular numbers 1, 3, 6, 10, 15. Those are the first 5 of them. And this process can be continued indefinitely. And so that leads me to a formula for generating the sequence of triangular numbers. If n is any counting number, I can use the formula n times n plus 1 divided by 2, as these are 1 times 2 divided by 2, 2 times 3 divided by 2, and so on. Now I said in the challenge that we are to take any triangular number, that's now n times n plus 1 divided by 2, multiply it by 8, and then add 1. And we're supposed to show that that gives the square of an odd number. Well, the rest is algebra. I simplify the expression by dividing 2 into 8, which gives 4. So we have that equal to 4n times n plus 1 plus 1. I distribute the 4n and I get 4n squared plus 4n plus 1. That expression can be factored into 2n plus 1 times 2n plus 1, which means it's 2n plus 1 squared. Now n represents any counting number. 2n has to be even. Add 1 to that, giving 2n plus 1. 2n plus 1 must be odd. So what we have here is the square of an odd number. So that proves it. That is my solution to my challenge from triangle to square. Thank you for watching this solution video.